Welcome back everyone, this is the Native New Yorker and this is part 2 of the dbx 3BX3 overhaul. In this episode, I'm going to first address the power supply issue, then I'm going to align, calibrate, and then test the unit with some music at the end. As you can see in the testing of the secondaries, I'm getting 11.81 volts on the positive and minus 12.264 on the negative. That's a difference of 454 millivolts, almost half a volt difference. To correct this problem, I ordered the voltage regulators and bridge rectifier from Mouser, and they finally arrived. My new toy also arrived. I've been trying to buy this Tooltop ET15S thermal imaging camera for a while. I had bait and switch and price gouging problems when I ordered it from Amazon and AliExpress. I ended up ordering it from evolve.com, and Bo from their customer support was very helpful. I'll put a link to it in the description below. I'm using this thermal imaging camera to check the temps of the power supply components. It's an awesome tool to have. I have the Pro version, which includes the macro lens. So I'm getting 126 degrees Fahrenheit on the voltage regulators and 120 degrees Fahrenheit on the bridge rectifier. Now on to the second stage of the heart transplant surgery. Just want to let you know that all the tools here were purchased by me with my own money, nothing was sponsored. If there's anyone who wants to send me some stuff to test and review, please contact me. gonna run some music through it now. It's a commercial track, so that's why it sounds shitty. But I'll put it through some music later and do a pre-post effects testing later on. The heatsink on the voltage regulators is just a thin piece of aluminum, so I ordered some heat sinks from Amazon for some extra thermal dissipation. Here's a close-up of the heatsink mod. After running music through it for about half an hour, the voltage regulators are now about 119 degrees Fahrenheit, and the bridge rectifier is about 100 degrees Fahrenheit. It's now within specs for alignment and tuning.
Later that night.
I'm using my Siglet scope and OWAN signal generator for the task. This is the grueling task of alignment, tuning, calibration, whatever you want to call it. The process is about 10 pages long in the service manual. I'm not showing every step of the process in this video. That's going to take too long and the majority of viewers are going to skip through it anyways. I'll just summarize part of the process to show how it's done. The signal generator is set at 20 Hz at plus 10 dBV. Using test point 10, I'm adjusting the VR704 potentiometer for the best low band RMS symmetry. For the mid-band, I set the generator at 100 Hz at plus 10 dBV, scope is on test point 12, and I mess with VR706 for the best mid-band symmetry. The generator is then set at 1000 Hz at plus 10 dBV, using test point 14 and VR708 to adjust the high band symmetry. Here I have the meter at test point 14 and I'm adjusting VR709 until the meter reads 0 volt DC. Fast forward a bunch of boring steps. Now I got the meter on the wiper of VR723 and I'm adjusting it to minus 6.75 volt DC. I don't want to bore you to death, so I'm skipping over to the testing of the music part. Put on your headphones and check it out.
Check the mic and make sure it sound right, boys.